So good day everyone. For today's video, we will discuss to you the engineered nanomaterials. For the overview, we will tackle about the introduction to nanotechnology and nanomaterials, nanotechnology and conventional technology, the formation of nanomaterials, and for the last one is the properties and applications of nanomaterials. The first one is the introduction to nanotechnology and nanomaterials. So what are nanomaterials? Nanomaterials are the cornerstone of nanoscience and nanotechnology. So these are tiny materials with higher potentials, and it can exist in different forms such as particles, powders, tubes, and etc. Nanomaterials has attractive properties and amazing technological possibilities, which can be one of the four basic types: metals, ceramics, polymers, or composites. Nanomaterials lie at the intersection of materials, science, physics, chemistry, and for many of the most interesting applications, also of biology and medicine. The first and broadest definition of nanomaterials states that these are materials where the sizes of the individual building blocks are less than 100 nanometer, a very small scale, at least in one dimension, nanometer equivalent to the diameter of approximately 500 atoms. Usually, nanomaterials are developed to show innovative characteristics compared to the same material without the nanoscale, features which includes increased strength, chemical reactivity, or conductivity. And for additional information, these are some of the advantages of nanomaterials. One of the advantage is their high porosity, which increase the demand of their use in the multiple industries. The second one is in the energy sector. The use of nanomaterials is advantageous in that they can make the existing methods of generating energy, such as solar panels. And we all know that solar panels is very useful and helpful nowadays because it is eco-friendly, and it can store energy that can be used to different households. And the third one is nanomaterials are also set to introduce a number of advantages in the electronics and computing industry. Their use will permit an increase in the accuracy of the construction of electronic circuits on an atomic level. So if there are advantages, there are also disadvantages. The first one is one of the main disadvantages associated with nanomaterials is considered to be inhalation exposure. So it means that nanomaterials can be a risk to our health because nanomaterials such as carbon nanotubes and nanofibers may cause pulmonary fibrosis, and other health risks are ingestion, exposure, and thus explosion hazard. The second one is there are still knowledge gaps regarding nanomaterials, meaning the manufacturing process can often be complex and difficult. So it means that experts need more knowledge and conduct more research in order for the manufacturing process to become more easier and less difficult. The next one is the overall process is also expensive. It is because the nanomaterials are not ordinary materials that can be seen or found everywhere. So that's why it is expensive. The last one is risk assessment concerning any potential environmental effects indicate that nanomaterials used in cosmetic items such as sunscreen, which are applied to the skin, run the risk of ending up in aquatic ecosystem after they are washed off. And we all know that there are living organisms in aquatic ecosystem, and it will be a harm for them, and it can result in the disappearance of different species. The next one is the uses of nanomaterials for agriculture, nanofertilizers and nanopesticides, healthcare, drug delivery, antibacterial bandages, for cosmetics, sunscreens, food sector, food packaging, food sensing, water purification, filter membranes, absorbents, and electronics. Nanostructured semiconductors which show nonlinear optical properties also exhibit special properties like luminescence.